Hi, my name is Mahesh Lavanis and I would like to welcome you to an overview of Bluecanoe, which is a system simulator. Today we'll go over some of the top features of Bluecanoe and also the design principles on which it has been created. You will see a video of me whenever I have to make a key point, so please keep that in mind and let's get started. What's Bluecanoe? Bluecanoe is a map-based system simulator. In the upcoming slides, we'll be going into detail of what exactly we mean by that. It is a Java web application portlet, which means you deploy it only one time on your JBoss portal server and people can access it from their web browser. This is a very efficient deployment model because you do not have to install anything on the client machines. Bluecanoe is completely GUI driven. There's absolutely no programming involved. So the barrier to entry for using Bluecanoe is very minimum. Last but not the least, Bluecanoe is available to you free of charge under the GNU GPL open source license. Bluecanoe is a system simulator, so let us understand what exactly we mean by a system. In the framework of Bluecanoe, a system is anything that has inputs and outputs. Here is an example of a system, a car engine. It has inputs such as fuel consumption and the air temperature, and it has outputs like the power that it will generate, the carbon dioxide it will emit, and also the waste heat that will be thrown out by the exhaust. Looking at another example, consider your neighborhood grocery store. The input is the number of customers who come into the store. The output is the sales generated and the overheads incurred by the store. For a third example, consider your school library. The inputs can be the number of members who use the library, the number of books the library has, and the number of librarians who manage the library. The outputs can be the number of bookshelves that will be needed, the number of chairs that will be needed, and the number of complaints that are received. A system is made up of other systems which are called subsystems. Here is an example of a system, the car engine, and it is made up of several subsystems such as the piston, the valves, the exhaust system, the crankshaft, and so on. Another example is your grocery store, which is made up of subsystems such as shelves, the checkout system, the inventory system, the refrigeration system, and so on. Any system can be part of a bigger system. So in this example, the engine is part of a bigger system, which is the car, which has other subsystems such as the transmission, the electrical systems, and so on. And our grocery store is a subsystem of a bigger system, which is the shopping mall, which has other subsystems such as a department store, a movie complex, a parking lot, etc. Systems can build on top of each other. In this example, the car is built on top of the engine, which itself is built on top of the combustion system, which is built on top of the ignition system, which is built on top of the spark plug. Systems can be chained. Here is an example of a chained system. The output of system A feeds into the input of system B, and the output of system B feeds into the input of system C. This is a simple chained system. Systems can be chained in much more complex manners. In this example, the output of system A feeds into systems B and C, and the outputs of systems B and C feed into systems D, E, and F. Finally, the outputs of the D, E, and F systems go into system G. A real-life example of a chained system is a jet engine. Here we see that there is an air intake system which feeds into the compressor system, which itself feeds into a combustion chamber, which then feeds into a turbine, and the output goes into a jet pipe, and finally the propelling nozzle. Now that we understand systems, let us see how Bluecanoe simulates them. We already mentioned that Bluecanoe is a map-based system simulator. Let us understand what this means. At the highest level, it means that Bluecanoe works out of data points and not out of formula. So what is a map? A map is nothing but a graph which relates one entity to another. For example, this map relates the power generated by a windmill to the speed of the wind. In our next example, we see a map of the bandwidth supported by a wireless station and how it relates to the power of the antenna. The next example is a map of how many commuters use the New York subway at a particular station and how it relates to the hour of the day. So from where does Bluecanoe get its maps? Bluecanoe pulls out data from the Archimedes database. The accuracy of a simulation in Bluecanoe is completely determined by the accuracy of the data that it got from Archimedes. The source of the data can be one of several places. It can be data that you actually collected live in the field. It can be the results of tests you conducted in the laboratory. It can be the output of specialized simulators, or it can even come from a computer program that you wrote yourself. Here is how Bluecanoe relates to Archimedes. A system in Bluecanoe can point to an experiment in Archimedes. Once you do that, the parameters of the experiment become the parameters of the system, and the results of the experiment become the maps of the system. Finally, remember that Bluecanoe works best for chained systems, and the chains can be as complex as you want them to be. With that, let us dive into Bluecanoe and see all these concepts come alive.